Okay guys, so today we're gonna solve the problem, the kth smallest element in a BST. So the problem says that given the root of a binary tree and an integer k, return the kth smallest element in the tree. Okay, so the question is pretty straightforward. So we're given a binary tree and we have to find the kth smallest element, meaning so if k is 1, we need to find the first smallest element. And if you look in this tree, the first smallest element is 1. So we'll need to return 1. And in this question k is 3, so we need to find the third smallest element. So the third smallest element, as you can see, is 3 over here. 1, 2, and then 3. This is the third smallest element, so we'll have to output the value 3. So how we'll solve this problem is we can go through the loop in an in order fashion. So if we can go to the leftmost node, so 5, then 3, then 2, then 1, and we can set a counter. Okay, and we'll increment the counter every time. So when we go to when we go back up every time, so for example, if it's 1 over here, and when we are at 1, we'll increment the counter and we'll check if the incremented counter is equal to k. So if the counter is equal to k, then we'll set another variable k smallest equal to 1. Okay, and then return. Okay, so if we are finding the third smallest element, then we'll go to 1. We'll increment the counter. So the counter would be 1 right now. If is 1 equal to k, then no, it's not. Then we'll just go to the rightmost node of the tree. So it doesn't have any rightmost node. Then we just return. On returning, we go to 2. Then we increment the counter to 2, and we'll check if k is equal to the counter, which is 2. So k is 3 and the counter is 2, so we'll just check if they both are equal or not. So here it's not equal, so we go to the right node and do the in order right. So it doesn't have any right node, so we go to 3, and when we go to 3, we increment the counter to 3, and then we check if k is equal to the counter. So here k is equal, and we make the variable k smallest or something to equal 3, and then we go to the rightmost node. In this the way we're going to solve this, all the nodes are going to be traversed in this tree. So even if you forget the answer over here, we'll go to the right node, we go to 4, then we go to 5, then we go to 6, and we get a time complexity of O of n. Okay, so how we'll solve this is we create two variables over here, counter and the kth smallest, self dot kth smallest equal to 0. Okay, now we'll create a function in order root, and we'll just check if root is equal to none, we'll return, and if it isn't, then we'll go to the leftmost node in the tree. So this is spelling is correct, right? Yeah, so we'll go to the leftmost node in the tree, and when we go to the leftmost node, then we check if then we'll increment the counter. So when we reach 1, we'll increment the counter plus equal 1, and then we'll check if self dot counter is equal to k. Then we'll make the kth smallest element equal to the current value of the root, and then we'll go to the rightmost node of the tree in order root dot right. Okay, and yeah, that's it. And then we just return root and return kth smallest, self dot kth smallest. Okay, yeah, on running the code, yeah, and submitting it, yeah, we get it submitted, guys. So I'll explain the code one more time to you guys. So cut this up, yeah, and remove this. So if let's assume k currently is 5. Okay, we need to find this value. So if k is 5, so let's make k equal to 5 over here. Okay, now if k is 5, so what the first thing we'll do is we'll go take the root and we'll go to the leftmost node. So leftmost node over here would be phi. Then we go inside phi's root dot left, then 3, then 2, then 1. So when we're at 1, our counter, we'll just increment the counter to equal 1. Okay, so currently it's 0, and when we reach 1, we increment the counter, and then we'll check if this counter is equal to k. So the counter is 1 and k is 5. So it's not equal. Then we go to the right node of the tree. So 1 doesn't have any right child, so we'll just return, and we go to 2. And when we go to 2, we increment the counter again, and this time it becomes 2. And we check if the counter is equal to k, so it's not equal. Then we and go to the right node. It doesn't have any right node. Then we just return to 3. When we return to 3, we increment the counter to 3, and we check if k is equal to 3. So k is not equal to 3. K is 5, counter is 3, so it's not equal. Then we go to the right node of the of 3, which is 4. When we go to the right node, we'll have 4 over here. So when we go to 4, okay, we'll go to 4's leftmost node, so it doesn't have any left node, and we go to and we'll increment the counter now. After incrementing the counter, this will become 4, and we'll check if k is equal to the counter. It isn't equal, so we just return. We go to the rightmost node of 4. It has nothing, so we return for 4, and then we return to 3, and then we return to 5. And on returning to 5, we'll increment the counter to 5, and we check if k is equal to 5. And if k is equal to 5, then we'll just return the output. So here k and counter and k are both the same, so 5 would be outputted as the answer over here. Okay, so yeah guys, that's how you solve the problem. And if you like the video, please do like, share and subscribe, and I'll see you guys in the next video. Thanks.